Well, all right, is everybody learning something? I told Lord Monckton, I said that was the fastest math class I've ever seen on energy balance, and I thought that was really good, because I think some of us that have been studying that, we need to know some of these details, some of these errors, and other things. But we're going to get right into it now, because we want all of our speakers to have as much time to talk as possible. Our first speaker today at this session will be Dr. James O'Brien. And he's done 20 years of ocean modeling before he got into some of the other things he's working on today. So he's affectionately known as Dr. El Nino, and today he's working on climate variability. So without further ado, Dr. O'Brien.
Thanks. Get around before I fall on my answer. Good morning, ladies and gentlemen. I'm pleased to be here. You might see the term "the truth" is in my slide. What I'm going to talk about today is local. No, they say all politics is local. I think that too many times when we take the global view of climate change, that we're missing out what's really happening. Sometime on your own, next time you're looking at the global IPCC pictures of temperature change, you might take a glance down toward Florida, where I live, and see that the models project almost no change whatsoever in 100 years with CO2 doubling. Also, we don't believe any of them, because I'm going to show you that basically the southern states in the United States are actually cooling down. We have literally a few hundred stations to demonstrate that. So, in this business about global climate change, we have a lot of problem with the truth. So I'm going to deal primarily with what's happening from real data, and you can make up your own mind based on what I'm going to show you. Now, here's an example of a lie. I would like to challenge all of you to remember, you've all seen this picture before. This is what Mr. Gore says is going to happen with sea level. The challenge is to, whenever you see this picture shown by one of the other side of the camp, listen carefully. I have never heard anybody say when this is going to happen. Okay, we're going to talk a little more about sea level rise later, but it's really important. They never say when it's going to happen. And where do I stand on global warming? Look at the picture carefully, please. This is a wonderful picture. I'm a conservative in the sense of energy conservation and renewable energy and other positive environmental actions, but I want to look at climate change in the Southeast based on data. So the topics I want to do is, first of all, I'm going to talk about a natural climate change, about where oranges used to be grown and where they will be grown 50 years from now in the Southeast. I'm going to talk about local cooling. And then I'm going to talk about the hurricane, since that is an obsession with the people in Florida, especially with the insurance rates going up fast. And then some little bit finishing up with freezes and tornadoes. The Florida orange story. I hope there's a few in here that are surprised that before 1835, the place to harvest orange for a profit was in the coastal counties of South Carolina and Georgia. Back when our country was formed, everybody down where I live in Tallahassee would have oranges. There was also a place where they grew them commercially, was in southern Alabama. Now they're down by Lake Okeechobee. I'm going to skip some of these lights. Okay, so in the 1830s, this is the place where you could grow oranges, but the harvestable stuff was in Georgia and South Carolina. And then, of course, they had 3 years of freezes. We call them killer freezes, because they don't just freeze the oranges, they actually freeze the trees, and so you have to replant, okay? And then in the 1890s, they were in northern Florida. Notice that western Florida is gone now. Then in the 1890s, there was 3 years of killer freezes, and they had to move Florida south. Now, this is taken from another source. So pre-1980s, these are the counties in Florida which had the major producers. And then in the 1980s, there was 3 major freezes, and now we're down here. Now, what's the problem with being down here? Well, the problem is called hurricanes. and hurricanes cause a lot of problem. Also, Florida's growing by 1,000 people a day, and so it's a heck of a lot more, you get more, to be a millionaire faster by building a town instead of growing oranges. We have other environmental problems like canker and other things like that. So here's a prediction for you. By 2060 or 2070, there will still be citrus grown in Florida, specialty crops, but you all, if your grandchildren will be getting your Florida oranges from Brazil because of natural climate change, of this cooling down that's very well demonstrated on multi-decadal scales in the southeast. So we're going to talk about sea level. Here's actual sea level rise at Key West and Pensacola. Talking to mostly an American audience, I'm a little reluctant that you may not know where these places are because the geography in our school is taught so poorly. But Key West is sort of down there just by Cuba, and Pensacola is over by Alabama. And the sea level rise in all of Florida is about like this. It's about 8 inches a century. But I showed you that picture before. I've been meeting elderly folks, not like me, you know, older, that live in New Jersey, North Carolina, and Florida. They're ordinary folks. Every single one of them are convinced their home is going to disappear due to sea level rise before they die. Okay? This is what's happening out there. So let's talk about sea level rise. From tide gauges globally, we're about 8 inches a century. We invested $1.5 billion in altimeters, and we have now about 15 to 18 years of altimeters. They measure everywhere, not just a handful of stations, and so they're measuring about 12 inches a century. Some say 14. But there's no acceleration observed, and I'll show you that in a second. So I was talking to my governor, Charles Crisp, who is really embracing global climate change like the governor of California, and I said, well, Al Gore says 20 feet. Let's see what happens if we get 5 feet in Florida. But let's do the following. Let's quadruple the current rate from 14 to, 4 times 14, 56 inches in 100 years. That's going to take 140 years. I said, you think that should be a political problem right now? The real problem in Florida is what the storms are going to do, okay? And the storms are really the important thing because so many of our people are moving to the coast. For those who international, realize that now already in the United States, about 50% of our population, lives within 10 kilometers of a coast someplace. And so the storminess on the coast, whether it's the West Coast or the Gulf of Mexico coast, the East Coast, is an important thing to worry about. And here's the famous picture again. And you'll have a lot of fun if you hear one of the other group talking about sea level rise. No matter how they present it, they never will tell you when it's going to occur, whether they say 20 feet or 2 feet or 3 feet, okay? And they don't want to tell you because here's a picture from the historical rise. The solid black line is some kind of average, and the little red line is what from the altimeters, which agrees with it. They are really independent measurements, and even IPCC has said that no significant acceleration in the rate of sea level rise during the 20th century has been detected. Now, let me give you a present. If you meet up with somebody who's a real aficionado of global warming, and they're going to mention that all the ice on Greenland are going to melt, you say, okay, let's give you that point. It's all going to melt, right? What's going to happen with sea level around Greenland? Actually, sea level around Greenland is going to fall by 10 meters because the land's going to come out. It's a very slow process, but the land's going to come out. And I tell you this as a present because it'll really upset them. They don't want to hear things like that. They don't want to hear the truth. And this was told to me by a scientist who actually lives on Greenland. So sea level rise is not that problem. And it's mixed up, of course, with other things like the sea level rise at New Orleans. New Orleans is 10 times what I showed you in Pensacola or Key West because of the sinking of the land. And so you have to separate these effects when you're talking about it. The East Coast of the United States has sea level rise probably 2 or 3 times what I showed you in Florida because of crustal rebound. And these are other facts to really have to look at. Now, surprising for some of you is the temperature story. This is not just Florida. I didn't publish the first paper on it. The first paper that I know of was published by John Christie about Alabama temperatures. So you take most of Mississippi, the southern 2/3 of Alabama, most of Georgia south of Atlanta, and all of Florida north of Lake Okeechobee, and you look at rural stations, which I'm going to show you a few, you're going to find out they're all cooling down. And this is a local anthropogenic cause. It's man-made cause why they're cooling down. The reason is because in the last century, we turned all the wetlands into farmlands. So in the wintertime, we get more radiational cooling and a little bit cooling. And I'm going to skip these. One of the things you can find, I didn't actually give the website for it, but we've taken literally hundreds of stations across the United States, but mostly in the eastern half of the United States. This happens to be Albany, New York. I didn't really have Central Park for this talk. The horizontal axis is probability, and the vertical axis is time. It's for 50 years, from 1948 to 2000. And what we do is we take 2 years at a time and sort it all out. We do that to get rid of year-to-year variability. Take all the temperatures for 2 years, sort them out, and plot the warmest temperature on your right and the coldest temperature on your left. And when the lines are all straight like this, with little wiggles, which is interannual variability, that means there's no warming. In the minimum temperature in Albany, New York, you can see that at the hottest temperatures, all the lines are straight up. The red line is the average temperature, and on this chart it shows that the average temperature for minimum temperature, not average, the average minimum temperature in Albany, New York in 50 years has gone up about 1 degree Fahrenheit, but it's hard to see it. Now let's come down to Florida. Here's in Tampa. Now when the lines start to tilt, so for example, here in Tampa, this is minimum temperature. You can see in the middle in the yellow range that it's tilting over. So a city like Tampa, you're getting this city warming, and so in the mid-range of temperatures, you're seeing that the tilting over means there's more warming. In the dark red, you see to have a few more days above 80. This is Madison, Florida, which is a small rural station about 30 kilometers east of Tallahassee. And you can see here that this is for minimum temperature. This is a much better way to look at it. You can see that for the average minimum temperature throughout here, the red line in the middle, there's been no change. But you can see that there's been some colder weather in the extreme cold that occurred in the 80s. That was the freezes we talked about before. But in the maximum temperature, there actually hasn't been. One of the facts that we learned recently was that we have over 100 years of daily temperatures for Miami, Florida. 100 years. Good. By the airport, okay? Do you take home the fact that Miami, Florida has never had a temperature of 100 degrees? I mean, you get 100 degrees in New York in August, maybe. In Washington, I know I lived there a couple times, you get it there. You certainly get it in Tallahassee if the Bermuda High sticks its nose over the continent, but there with the sea breeze. So the climate has to be taken into account. But let me show you a closer look at some stations. Defuniak Springs is a small station located near Eglin Air Force Base in the panhandle of Florida. It's a farming country, and this is the unadjusted data. So on the left-hand side is the annual minimum temperature average, and then the right-hand side is the annual maximum temperature. And there is some interdecadal variability, but you can see the cooling that's occurred in this rural station. And the horizontal light green line is actually our government service says that the average temperature is the average for the last 30 years. And you can see, what they're currently using for the average in that period. Here's another station, which is also a rural station in southern Florida, and we have many of these. Again, it's not as dramatic, but you can see also the cooling that's occurring here. And again, literally a few hundred stations in Mississippi, Alabama, and Florida and Georgia show this cooling that's going on. And I emphasize this is man-made, okay? Now, if you go to a city like Fort Myers, which is a growing city, and at this small airport that's inside the city, that's where the data is taken, and you can actually see that it's warming up. One of the problems I found in looking at the National Center for Climate data is when they adjust the data, a lot of times now they're adjusting the rural stations to agree to city stations, which makes everything warmer, which is really, I've told my people we have to take the real data and hide it, like put it in a vault. And I want you to do that at home. Get the real data and hide it, okay? Because if you don't, you're likely to see it being changed for you. Now here's a very interesting example to show how the physics works here. Belle Glade is a tiny little town. It has a population of like 400 people. It's on the southern side of Lake Okeechobee. You would expect it to be cooling down also. But my God, look at it warming up. What's going on here? Okay, well, if you visit this small little town and drive around, everything you're going to see is sugar. Back in 1900, they didn't have sugar there. Now they have sugar everywhere. Sugar is one of these crops that has a huge amount of water in its leaves. So in the wintertime, when you get the cold temperatures, you know, the sugar cane is providing a huge amount of water in the boundary layer, which is just like the opposite of we had the other cases. You take away the wetlands, you get more radiating cooling, you don't have water in the boundary layer. When you have sugar there, you get the warming. So this is a nice example of a very rural place where man locally has modified the climate by how he's doing things. And there's nice studies, which I'm not going to go into now, which looks at the land use practice by Marshall and Roger Pilkey Sr. Okay, hurricanes, of course, are a big thing. This is the landfall hurricanes. I want to emphasize this. It's very important. I use hurricanes that hit the United States or Florida in my studies. And the reason is that since at least 1900, maybe even in 1880, no large hurricane which hit the United States, it was reasonably populated, would go unknown. Whereas hurricanes can be on the ocean before 1970 when we had satellites and they weren't even there. On the contrast, what's happening now is that, you know, remember 2006 we had to go into the Greek alphabet for hurricanes? What's happening is that, you know, we have these satellites out there, they see something that might be a hurricane, you send a plane out to it, it gets a name, right? And 6 hours later, it's dead. So we're measuring all kinds of very small storms that never get to be hurricanes, but they get to be named, so we get into the Greek alphabet for naming them, okay? We have a real problem with our data. Some of you remember when Hurricane Wilma was headed for Cozumel, Mexico, and the press told you that in the Atlantic, they measured the lowest central pressure ever measured in the Atlantic. What they forgot to tell you was that 5 years before that, it couldn't be done because it was new technology. They actually drop a drop sound down through the middle of the storm, and when it hits the ocean, it says, my pressure is this, okay? Back to the plane and back to the press before you land, all right? But they forget about the fact that it's new technology. And anyway, you can see no increase. This is just done by decade. And this is our famous graph about El Nino. I want to point out for people who don't worry about it, but this is the Exceedance Curve. So the way, if you look at the line 2 or more hurricanes and come up, when El Nino was coming, it's very important, when El Nino is coming to be a big dude in the following winter, okay, then the summer before that, then the hurricanes are suppressed, and we know the physics very well. I won't repeat it here. So in 100 years, we never had a Category 3 hit the United States anywhere when El Nino was coming. That's why we made the line go to 0, instead of just fitting, you know, a Poisson distribution and having it tail out over there. On the other hand, so it's 25% probability you get 2 or more, but 2, 0, or 1. The green is neutral. That's not normal. Neutral is those years, the 50% when it's not El Nino or La Nina. You get up to a 50% probability of having 2 or more, and when La Nina is there, you get up to 80%. Although this last year did disprove that, and it was a problem. So what I went back and I plotted the cube of the wind speed. I just went too far. Anyway, I'll come back to that one. And I want to filter it a little bit. So here's your, course, senior level course in filtering. On the left-hand side, if I just have a trend plus a low frequency period, and then on the top right-hand side, I have a low trend and low frequency period, and I apply this little thing called a Hanning filter, which is a 1/4, 1/2, 1/4 average. Then on the left-hand side, the trend goes away, but the low period is there. And on the right-hand side, the high frequency goes away. For those of you who know the math, basically, we completely take out 2 delta T wave and about 60% of a 4-year, kind of thing, okay? And if I have both the high frequency and a low frequency and just use the same filter, I still have the low frequency and the trend. So on that data I showed you before, I did this, this is the power index, which means you have, each year you take the landfalling strength and cube it and add it up. And you can quickly see that if you look around 1970, I don't have wish I had a spotlight. Around 1970, there's a minimum. That's about the time we had the first satellites. First of all, this goes all the way back to into the 1800s. I don't really trust the stuff before around 1870. A poll. Does anybody see a trend? There's no trend here. I showed this chart in a debate with Judith Curry in front of 500 people who deal with emergency management in the Southeast, and not a single person could see a trend. There's just no trend. And I have a student finishing for the Pacific, and there's no trend in increase of strong hurricanes. $500 extra to make your house safer. Okay, strap it down. You use 6-inch nails instead of 4-inch nails and things like this. And so all the homes that were built after '92 survived. The ones before had very serious damage. And that mitigation is very important, and we can live out the hurricane business. Okay, we have freezes. We discovered almost all the freezes occurred during a neutral period. And for those of you who are meteorologists, it has to do with that. In El Nino, the subtropical jet stream is a dominant jet stream. It does not allow the cold air from Canada to come to the central Florida. And when La Nina's there, you have the jet stream you have this year. It doesn't allow the cold air to come from Canada. So except for this funny one in '97, all the freezes. So we can actually tell people who, and I won't go through that, we actually can help them make decisions ahead of time by telling them this year the probability of freezes for your county is gone up, the odds are 3 to 1 greater, okay? And they can think about doing something in anticipation of freezes. And this is part of what we work on it. Temperature extremes. This is Arcadia. It's a local station. Forget about the stuff on the left. On the right, this is the number of days below 32 from, you can't read it, from 1900 to 2005. You can see that the cold days are increasing. On the bottom is the number of days above 95. You can see that there's been no trend. Madison's on the left. This is rainfall, the number of rainfall days with more than 2 inches. No obvious increase. And Arcadia looks like there is some increase. The general wisdom in the United States is that the amount of rainfall falling typically in the United States is not increasing due to climate change, but more of it's coming in stronger storms. I think the jury's not all out, but that's the conventional wisdom. So these are things to look at. Because the point about this kind of talk that I'm talking about is we have the data, folks, okay? And if it isn't squirreled away by the people who have a different story, you can look at the data and see what it says instead of just listening to your cub reporter. Okay, in conclusion, I would just like to say that we have huge climate change in the South. You've all read about how Atlanta was about running out of water and the state fights between Georgia, Alabama, and Florida for water rights of a major river basin. Atlanta running out of water has nothing to do with climate change. It has to do with horribly bad planning, okay? Hey, you can see, you knew that bad planning. What did they do in Georgia when it really got serious? They prayed. And unfortunately, it rained the next day. Okay? So I think we need to do this. What I recommend is that you do this in other parts of the United States and the world, is get your local data. I know with the skeptic things that it's very nice that we see folks from other countries that are, seeing what's happening locally and reporting back to us, because, no matter how many newspapers I read in the United States, I'm not going to read what's going on in Argentina or Peru or Brazil or New Zealand or Australia or China and other places unless we have this reporting back about what's really happening with the climate. Thank you very much.